Okay, so today we want to describe a problem we encountered while developing our React Native application in Soludo. And to describe the problem and the solution we found for it, we've built a React Native app, an example app. We call this app Who Pooped. It shows a list of the dogs in our office, and when you tap on a name of a dog, it shows you a little toast that says that this dog made a poop. But as you can see, the toast covers the tab bars on the bottom, right? So that's a UX bug we have. So we got a task from our product manager to move the tabs to the top part so they won't be covered by the toast. Let's go through the steps that we have to do to actually get this fix delivered to our users. We call these steps the normal process. So we start by writing our code and tests, right? We create a pull request for our repository. Next step is to fix or merge according to the pull request results. These steps are up to me. They'll be done as soon as I finish to run these steps or actually doing them. The next step would be to wait for the CI to finish, the entire app CI, right? And then wait for the release process to start. Now, these two steps are up to other teams in my company. The release team or the delivery team that actually manages these processes, they don't actually care about my team's KPIs. They'll just do it at their own pace. The next step is wait for the App Store evaluation, probably get declined for something. These steps are up to some third party that definitely doesn't care about me, my team, my KPIs, or my users. They only care about their ecosystem. The next step is to wait for the release manager to actually tap the release button, and then if I have a bug, I have to go through all of these steps again, right? We don't like this process, and as mobile developers, you all probably know this email you get from Apple that someone added an audio something, UI background something, for just a small change of moving the tab bar to the top, and your users suffer through this kind of change. This is not a normal process that we want to work in, right?
So, while looking at the steps that Elad mentioned, we discovered that we were facing something we call the nightmare, and we tried to conclude them into like bullet points that we can actually solve. And we said we are facing short development time, but it takes us a really long time to deliver. We are blocked by the entire release process of our entire teams that work on the same app. And it takes a really long time to go through the store evaluations, Apple Store and Google Play. And it actually sucks. We don't want to do it. So we were thinking, what is the dream? Like, how do we actually want to develop native applications? We would like to release as quick as development. We would like to release independently, not related to other teams. And we wish we had no evaluation time. And up until this point, if some of you may know, Code Push is really helping for this tree stuff. But the thing with Code Push is that it bundles your entire application, and every time a user reaches out, it will download the entire application, which is good and maybe good for other places. But for us, we wanted to only ship the changes. I don't want to ship the entire application. I don't want to, again, be related to other teams that work on the same application. So we were thinking to ourselves, what if we can deliver small bits of code and evaluate on runtime? Is it possible? Is it possible on native? Let's try.
Okay, so we're gonna do a live demo attempt of getting this type of process going. The first step in our demo would be to get a bit of familiarized with our Office Dogs application. So as you can see, the main view is just a simple React Native app, right? We have some views, some text, we have native base for some fancy UI, but nothing too interesting. we want to move the tabs to the top part. Let's look at the code of the tabs controller. As we can see, the tabs controller position is controlled by this property. But if I change it, if I change it right now, I'll have to bundle up the entire application and go through the entire normal process, which is something I don't want to do. So let's try and take this code and move it outside of the app. The first step would be to create a new folder, which will be a sibling of our application. We'll call it, tab bar. We'll create an index.js file, okay, and copy the code here. Now, when I look at this code, if I send it over to my application, I can't actually evaluate it on runtime, right? I need to transpile it to something that is actually runnable or evaluatable. So we're going to use a zero config bundler that's called Billy. It's installed on this machine as a CLI. We'll run it, pass our code through it, and let's look at the output. Okay, so this is the output of transpiling this code. You're probably familiar with it if you know React. You can see React create element. We can see the property we want to pass in and change at a later time. Two interesting parts about this code. It expects to have two globals. One is a require function, right, that gets a string and returns a module, React for React, native base for native base. The second is to have a module object, like a global module object, on which it will create an exports property. And on this property, I'll expect to find my components code. Okay, let's remember these two things. Now the next step will be to have this code available for delivery over the air. We'll use some, some CLI tool that's called Live Server that will create just a simple file server. You can see that's exactly the code we've seen before. And the address is written up there. It's localhost 8080 dist index.js, right? Okay, so now I have my code available over the air. So the first step would be the next step would be to actually download it in the app and evaluate it. Let's create a new file. It's called component loader. Right. So we'll start by creating an async function that will download the code. That'll be our first step. Yes. We'll fetch it from the same address we mentioned before and convert it to string. Now that I have the code, I need to create the globals we mentioned before, the require and the module object. Let's start by creating the require. We'll map the strings that we know this code expects to have to the actual modules, right? So we'll import React, we'll import native base. And we'll just map them to the correct objects. Now we'll create a function that will use this object. It'll get a string, and it'll return the correct module. Pretty simple. Next step would be to create the global module object, just an empty object. That's all we need here. Now we need to evaluate the code. We'll define a new function. We'll say it has two arguments. One is a module argument, and the second is the require function. And the third argument would be our code. And now we'll just run it with the appropriate arguments. And as we saw earlier, we expect to have an exports property on the module object, right? So that's what we'll return. Great. So now we have a function that downloads the code, evaluates it with all the expected globals, and returns the component. Now what we have to do is actually render this component. Let's create a component that will use this components loader. First, of course, we have to import it. Right? Let's call our component tab bar. And this tab bar will first use the useState hook to create a components container. We'll initialize it with an empty object. Nice. And now we'll use effect to download the code. And as soon as we have the component available to us, we'll use set component. I'm running. Sorry. Okay, so now we have the view. We'll use set component to actually save the view on the object. Right. And finally, we'll return, if we have the component available to us, we'll return it along with the properties that we're getting for this component. Perfect. And if not, we'll just return an empty view or something. Doesn't really matter. Next step would be to actually use it in our main view. So now we have a tab bar in our application that uses the components loader. And if we look at the import statement, we see that the tabs controller is no longer needed. And even more, I can actually delete this tab controller file, right? I don't need it anymore. Let's try it out. We have the app running. Save the file, please. Yes. We have the app running. Let's run it. Okay. We still have tabs. That's good. But that's not exactly what we wanted. We wanted to have the tabs on top. Let's go fix it. So the first step would be to move them to the top. Now we'll transpile the file, and we'll have it served. Thank you for showing. Let's refresh. Tabs are on top. We didn't actually have to reinstall the app or do any bundling of the entire JavaScript. We just had it delivered to us over the air. Really useful.
Cool. So we actually managed to achieve our dream, okay, by simple lines of code. And if you think about it, we created web delivery for native application, but better because we only ship the component changes, right? This is really good. But how do you store these components? Do I have to download the code every time I reach out to the application? How do you keep track of the versioning of your application and dependencies and your component dependencies? How do you develop locally? And how do you integrate it into an existing app? So we faced all of these questions, and we came up with a solution we call Dynamico. It's an open source project we developed. We use it we use it in production for over 2 years, more than 2 years now. And essentially, it's a JavaScript framework for JavaScript applications in order to achieve continuous delivery or just shipping some small bits of codes. So let's take a look of how Dynamico actually works. And it might sound familiar because we just did it. I have an application, and I define that the tab bar per se is a dynamic component. I have a registry, which is a server. Think of it as the NPM of my components, right? It keeps all my components and their versions. And I have a separate component which is developed separately from the application. A component registered to the registry. The application asks for this component, gets the component, and gets the latest version of this component. So if I will publish a new version, it will automatically figure, okay, I need a new version, and I can actually run it. So this is all great, but we should actually think of it as my entire application should be dynamic. I don't need to be strained by any store and evaluation time. So let's take a look actually how Dynamico really works. Okay, this is with no Dynamico.
Yeah.
So first of all, we have to kill the bundler of the old example. So give us 1 second.
Let's just have a debug version up and running and go through the app.
Perfect.
Take it away.
So if you look now at the code, this is the same application as before, just with a few tweaks. We use it with Dynamico. Hit save so it will look better.
Right.
Perfect. So you can actually see this is the same thing as before. We have still the tabs controller, but this time when you go into the tabs controller, it's this code. What we actually say is that we have a client which is written for React, but there are other framework implementations. And all I say is give me tab controller. I reach out to the registry and ask for tabs controller, and I have a fallback property, and I tell it while you fetching the code render this text. And if I go back to the main view, I can see that we have dynamical provider, which actually gets the dynamical client. The client itself tells the components what URL they should try to go and fetch components. And the dependencies here are basically the same as before. If you go to the resolvers, you know this code, right? You've seen it. But we actually also add the versions of them. So we go to the package.json and take all the versions, so we can we can send the dependencies of your application to the registry, and once a component is registered, we can find a match. So you can develop one component that can fit to multiple applications, and if your component, let's say, relies on a version that your application doesn't have, you won't get it, because we want to make sure that the code will actually run. Next thing is we use some local cache, so we can save these components, and then we have this fetch. Right now it's the global fetch, but you can use Axios to add middlewares for authentication or whatever fetcher that you want. And that's it. I want to show you this application here. It will be on screen. This application it's like a production application. It's connected to the internet, not to this computer. I'm just screening the screen over here. So you can see there's no strings attached, nothing below, right? And now I want to move the tabber to be on top. Okay, let's do it. So I'll go to the tabber component, which is developed, as you can see, outside of the application. And I will change, again, the tabber position to be on top. Okay, I will use our own CLI that we developed on top. Yes, 1 second. We've written a CLI to help you to work with dynamic components. It's called DCM. And I will just do DCM publish, but before that, I will make sure that the version, I bump the version, just as you do for NPM packages. I raise the version and then I publish. So I'll do DCM publish. What this will do, it will bundle the code with using Billy and then send it to the registry. So it's published. I will close the application.
No.
I will close the application, open it again, and it will be on top. I didn't go through the store, and it all happened instantly, right? So this is cool. So as you can see, there's a tab here that says add dog, and I want to add a form over there so I can add a dog. So let's see how you can actually develop locally. So I will create a new file called, new component called dog form. And for now, I'll just copy and paste the tabs controller. And I will say that I want dog form component, sorry. I will also add dev mode true, which will tell this client to actually look and search for a local development server who will serve the component that we're actually trying to develop. I will go and link it on the tab data. Dog form. And I will go and create a new component actually. So I will create a new folder called dog form. Great. And now I can actually go and use again the DCM, the CLI, to init my component. It gives us some kind of bootstrapping. So I'll do DCM init. And it asks me what kind of language I want to use. I want to use TypeScript. Let's do TypeScript. I use React Native and whatever version I want. So the cool thing about it is that I can actually develop my components in TypeScript even though my application is written in ES5 or whatever language that compiles to JavaScript. It doesn't matter. So I will go to the dog form. Let's say your dog form component. I will do yarn so I can get all the dependencies. Yarn install, yarn. So So in the meantime, let's see the application running. So as you can see, refresh it so it will update. Okay, so it will change the add dog tab, right? Can you click it?
Not yet. This application is not the same as before. This is a debug version ran on a simulator, right? Okay.
So, right, I will do DCM start, which will actually bootstrap the component, bundle it, and use live server to serve it, as we did before. And now, if I look at the application, I will have it loaded in a second. Can you try again?
Yes, of course.
Yeah. I will have it loaded. So you can see if you can read your dog from component. So let's change it to 404 fast is awesome. And as I save, you'll see it will bundle again and we'll change it instantly. So we get sort of live reloading and automable reload. So this is really cool. Let's say I love this form. This form is amazing, and I want to publish it to the registry. So I will just do DCM publish, but it won't work because I have to tell the DCM which registry to work with. So if you can see the DCM config, there's no registry. I will just copy and paste the registry from the tabs controller. Okay. And one thing before publishing, I have to make sure that my component dependencies are the same as my application dependencies. So you can see that this component has a pure dependency in React Native and React in these versions, and my app has a higher version of React Native. So we want to match that. We want to have the same dependencies. Place here. Cool. Here as well. And now we can publish. Let's DCM publish. Again, it will bundle. But one thing we forgot, we have to change the name for it. Right.
Okay. This name has to match.
Yep. Has to match the component that I'm asking for. We did dog form, so we want to match. So again, it's published. Perfectly bundled. It's been published to the server, and now we can see that my application got it instantly from. Close and open, and you can see it's got it from the registry. It's really cool. So,
right. So what did we see here? We saw the process of updating an existing component, moving the tabs from the bottom to the top without publishing an entirely new version of the app, right? And we saw how we can actually create a new component by just having a placeholder and just doing the development way after the app reaches the user's phone, right? So that's pretty cool. That actually leads us to a whole new process. Let's compare the new process to the process we showed earlier, the normal process. We'll call this process Dinamico. Okay, so the first step was actually that we wrote our code and tests, right? We created a pull request to our repository. We fixed our merge based on whatever the feedback was. We waited for the feature CI, which was the publish. We actually published it ourselves. And if we had a bug, we just go back to step one, write code and tests, and fix it up. All of these steps are under my control. I actually change the code on the user's phone without having to be dependent on others, not other teams and not other third-party crazy companies that have their own demands. And the interesting part about this comparison is that even these steps are not entirely equal, right? So writing the code is actually the same, and creating a pull request is pretty much the same, but merging code to a small feature repository is way easier than merging your code into an entire application, right? Waiting for the CI of a specific feature is, again, way easier, quicker, and much less error-prone than waiting for the CI of an entire app. I don't have to wait for anyone to tell me to release. I definitely don't have to be evaluated by anyone, and no one can decline my change. I can just do it myself, and I don't have to wait for anyone to press the release button. I can just do it myself. This process can take up an entire sprint, plus the time it takes you to run your CI, plus the time it takes you to decide to release your new version. With Dynamico, this is done as soon as possible, as soon as you finish your changes.
So if we got you interested, please go to GitHub Soluto Dynamico. It's, again, open source. We use it in production, and we actually would love to have some feedback. Thank you. So please go ahead, do a start. There are tutorials and getting started, waiting for you to start. And again, we would love your input. Is there any questions? Yes.
So my question is, can we prepackage components? So question is, can we prepackage components so it will be available if somebody installed the application and do not have internet or mobile now?
So this is one of our one of the stuff we want to do in our roadmap, to have some sort of Babel plugin or one step in the build process that once you do build, it will fetch the latest version and pre-pack it, and then you can have it offline, and then next time if the user have a new version, it will get it automatically and it will pre-load it in the cache. So it's definitely on the roadmap. Go ahead.
Thank you for your presentation. I know that Apple rejects apps with code push. How are you resolve this situation? Thank you.
So, whoa, sorry. Huh. Am I on? Can you hear me? No, huh?
You should show it. Just show it.
Okay, so, no, I'm kidding. Thank you. Okay, so thanks for asking this question because we came prepared. We actually have it written in our repository taken from Apple's guidelines. So their main issue with changing code in runtime is that you change the essence of your app. So a nice example Lab has is that if you publish a calculator app and later on turn it into some kind of totally different, I don't know, social media app, that's not cool with them. But if you take a calculator app and then upgrade it to a scientific calculator, they're good with it. So you can check out their actual phrasing of the issue, but interpreted code is maybe downloaded as long as it does not change the primary purpose of the application. And we actually push you to be more compliant with this way of work, right? Instead of like in code push when you actually bundle up the entire application.
Your component has no limitation on a maximum version of component. So if you publish the new version of component, you should retest all your applications that uses this component, that they are not broken with this fix of this component, yes?
So the versioning of the component are SAMver. We encourage you to follow the SAMver versioning of your component. You can create integration tests between your application and the component and check that nothing breaks. And it's totally up to you. Like you would do exactly the same if you were developing the component locally. So it's not that different. It just makes you think of component development differently.
It also, sorry, thanks. It also allows you to actually divide your integration tests into specific changes. So if you change only the tabs, you'll have to test only the things that rely on the tabs, not the entire application every time for just a simple change, which is faster probably. Thank you.
Thanks for the great talk. I actually have two questions. One of them is that is there any other way rather than just like defining package JSON to do the similar? Because right now each of those components are going to be considered npm packages. Goes well with monorepos, for instance, but is there any other way to define manifests or meta.json files for them, keeping them all into one code base?
Currently, this is the way that it works for us, but everything is it's an open source, and we try to make it as agnostic as possible, so you can rewrite your server and define a new mechanism or another mechanism of resolving components. If you have a better idea, just come and talk with us. We are welcoming new ideas, but currently you have we encourage developing separately, but you can have a monorepo with all the components. It just depends on how you divide your folders.
So the next question would be, imagine one of the users is behind the content network, and for some reason fetching the latest version of the components will run into problems. So, and they haven't encountered a bug. And when they report it, is there a way to tell the user to tell me which version of the component that you run? Because it means that not only you have to test for the combination of all the components, but rather you have to keep integration tests between the previous versions too.
Right. You want to take it?
Yeah. Thank you. So the issue is if the user can't actually get the latest version of the component while they still have an issue, right? So we need to improve the observability definitely of the components that are sent and integrated into different apps. Currently it's achievable, but it's up to you. Definitely open to suggestions as to how to do it properly. With our implementation, we just basically rely on logging it and monitoring the requests and figuring out, which version is able to get which component. But yeah, definitely it can be improved and be way better than what it is today.
I will add that in production we have a layer on top of this framework that is sort of remote configuration. So our product managers can actually decide which component to show and have a gradual release. So that means you can sort of know what version is being sent to the users by the gradual releasing. But I get your point. It's a really good point.
Any more questions from the room? Okay, actually I have a question.
Yeah.
During your demo I saw that you use HTTP, not HTTPS. And actually any runnable code that is downloaded from the server, it should have some additional security and integrity things. So what exactly mechanism you use in your system to provide a good level of security of downloaded code that it is not bad behavior code, maybe without man in the middle attack and so on?
This is a great question. Go ahead.
Thank you. Okay, so at our company, we rely on securing the storage, obviously, where we store the components, right? And the second part is that you need to secure your registry. So to publish new components, you need to pass through authentication and actually be part of the internal network. So we guard that. So publishing components is hard. The second part is fetching the code and actually relying on the being assured that the code is safe, right? So we rely on certificate pinning, and we say, okay, this is definitely the correct server. So if the storage is secure and if the registry endpoint for publishing is secure, we can rely on it. We're currently working on adding a way for you to add some way to check for integrity and maybe even add code signing if you want, but we're not supplying any solution for that currently, and that would be probably on a roadmap, but yeah.
Also, the way you define the server is just an express middleware, and this middleware you can put whatever authentication you want before that. Also, you can have a way which is already supported to have a server which only for publishing and a server for only for serving the code. So you can separate entirely these two mechanisms, so you can be sure that no one can have access to it. We are really eager about our security in Soludo, so these problems that we are facing, and everyone asks this question every time we give this talk, so it's a good question.
Thanks.
Okay, any more questions? Let's look at our 404 app. Actually, it also uses React Native and it's downloadable bundle inside the native app. Because so we basically use the same. We have the same task of somehow like updating our applications in runtime after we push it to the store, but it is done on native side.
Oh.
You guys have it.
Cool.
Okay. So no questions in the discussion page.
Cool. So just to summarize, you can see all of the code examples here in this address. Another dynamical conf example. You'll see both no dynamical and with dynamical examples. And again, this is the repository on GitHub. Give us a star, open an issue, open a pull request. You can feel free to reach out. We both are on Twitter, DLAT. This is our handles. Again, feel free. And thank you much for coming. Spasibo.
Thank you so much.